Hey T-Sauce, Enzo here. What is a gyroscope? Now that's a complicated question. This is, and this is. But how do these work?
Excellent question, Lorenzo. To accurately answer it, let's examine this paper from MIT's 16.07 Post-Tensorial Physics that describes the method for employing Euler angles to solve angular momentum equations.
Psych! Burn! Look at Randy Orton slithering. Watch out! Watch out! Watch out! Watch out!
Let's see how this works. Woohoo! That's straight on. There we go.
Here we can clearly see the top is spinning in a counterclockwise direction. As the top spins, it is also rotating in a circle. Why doesn't it just fall?
Instead of thinking of rotating bodies as one solid object, picture a bunch of different spheres rotating around the center. The top is tilted, so it will be pulled downwards here and pushed upwards here. Because it is spinning so quickly, before this point falls over, it has already moved to the side, and instead of falling straight down, it will move sideways. This happens again and again, causing a phenomenon known as precession. This explains why gyroscopes rotate without falling down, but what about its circular motion on the floor? This is easy to understand if you notice that the force of gravity is creating torque, and it is making the top rotate about its center of mass in the C-plane. The tip of the top is sliding perpendicular to the force of gravity, parallel to the resulting force. Thus, the top creates a circular path on the floor.
In helicopters, gyroscopes are used to move forward, backwards, and side to side. Here you can see the principles that Jose touched upon previously. Helicopters move their blades to different angles, 90 degrees before the direction they wish to move. If you wish to lean forward, you rotate the blades to a higher angle 90 degrees before 12 o'clock on either side, depending on the rotation of your blades. This premise is shown well in Smarter Everyday's video describing the subject.
The tire rotates in the same plane as we're moving this bar, but when it's spinning, it's going to be different.
Let's just check it out. Yep. Here we go. I used to play with my mom's exercise machine when I was like 5, so I'm highly qualified to apply angular momentum here.
There we go.
Angular momentum applied. It breaks.
Trying to control this thing. All right, so now we're going to do the same test again. We're going to apply force straight up here, and it rotates 90 degrees from where we apply the force.
All right, this principle is called gyroscopic procession.
Correct.
And that's basically the force is applied orthogonal to the plane of rotation. It acts 90 degrees out of phase to that applied force.
Physics gang, stand the bleep up.